Good morning all. I will share my screen. Okay, today we will start the chapter number 3 named as a process management. In earlier chapters we have seen the definition for the processes. Okay, the process management in detail we have to see in this chapter, that is the chapter number 3, how the actual process is going to be created, terminated, suspended, and sleep. So these are the some functions of the process management, and we need to see how these are going to be happen into the operating system. So the process management is the one of the task of the operating system. The we will go through the one by one with these all the points. And the first one is about the an operating system executes a variety of program. Okay, we can, so the program in the batch system is called as a jobs, and in the time sharing system it is called as a user programs or the task. When we are going to refer to the batch system, then it becomes a job, and when we are referring the time sharing system, it becomes a user program or the task. So we need to remember these two things, that how we are going to call it is a program or the job. So job and the program is nothing but the same concept, but in the batch system it is considered as a job, and in the time sharing system it is considered as a program or the task. Then in some of the textbooks uses the same terms, job or the process, almost interchangeably, but it is the same thing. We can refer it as the same one, job and the process. So you have to remember that the job and process is both are the same thing. We can interchangeably we can use it. And then we go for the definition of the process. And the process is nothing but the program in execution. So program execution must process in a sequential fashion. So many of the times we have seen the definition for the process. So process is nothing but the program in execution, and the program execution must be progress in a sequential fashion. In the For example, we can take this any kind of a C program or C++ program or any programming language program that should be, by default it is in a sequential fashion. Now, the flow of the program can change when there is some kind of a loop is there. Suppose you have the while loop, suppose you have the statements like a jump, then the program sequence is going to be changed, but by default it is in a sequential fashion. What is meant by the sequential fashion is nothing but the when there are the number of instruction. For example, we can take it, there are the n number of instruction, 1 to n. Then first of all the process is going to execute. Okay, in the process first of all we need to execute the instruction number 1, then 2, then 3, then 4, up to the n. Okay, there may be a change in sequence if there is some kind of a loops are there, just like a for loop, while loop, or any kind of a loop is there, then there is a change in a sequential fashion. So that process has the multiple parts. So which are the multiple parts it includes? The first of all is the text section. Okay, we need to see which parts are included. Okay, the first one is the text section. So we have the multiple parts of the processes. The process includes which parts? The first part is the text section. The second part is the program counter. The third part it is a stack. The fourth part it is a data section. Then next part it is a heap. So each and every part having its important and its function to do. So one by one we will see what the text section is going to be included. The text section includes the program code. Okay, what is meant by the program code? Suppose you have written any kind of a C program, and that we are going to be compiled. When we want to run it, okay, that we need to compile it. How we are going to compile it? We are going to make the program into the turbo C, then we are going to compile it, and then we are going to run it. Okay, and that compiled code is going to be considered into the text section. Understood all of you? what the text section is going to be considered. The text section is going to be considered, that is the compile code of your C program. Then the uh, next part is the program counter. The program counter is nothing but it is just a counter for the current activity. Just like in a C program, if you have written the 20 line of a code, then we have the instruction number 1, instruction number 2, instruction number 3, up to the instruction number 20. Okay, we have the 20 line of a code. So at this time or at this second, which instruction we are going to execute it, that is decided by the program counter, and that is pointed by that program counter. It is just like a pointer to the current execution instruction. That is nothing but the program counter. Then next part is the stack. Okay, then what stack contains? The stack contains the temporary data. Okay, means many of times we are declaring the temporary variables, local variables, function parameters, return addresses. So these all the kind of a data are given, or we are going to put it into the stack. Okay, and when your program is going to be over, then that data is going to be flushed out, or simply we are going to remove it because it is a temporary data. So this kind of a data, temporary data, is going to be, we are going to put it into the stack section. Then next one, consider as a data section. We are declaring the many of the global variables and the static variables in the program, so that all the global variables and static variables are going to be put into the data section. So that is the use of the data section. Then here the next section is the heap. Okay, heap contains the memory. We are going to, many of the times we are using the calloc function, malloc function to run the or to allocate the memory at the runtime. Okay, so these kind of memories are used by the heap section, in the heap section. So these are the different parts of the process. I will repeat it again. Which parts are the process includes? The first one is a text section, then next one is a program counter, then next stack, then data section, and then the heap. What the text section contains? The text section contains the compiled code. Then what is the use of the program counter? It is nothing but the just a pointer to the current instruction that we want to execute. Next one, it is a stack. What stack contains? The stack contains the all the local variables. When you declare the intc, intb, intd, so these kind of all the local variables, local addresses, function parameters are going to be considered into the stack section. The next part, it is the data section. The data section contains the global variables and the static variables. And the next one, it is a heap. Okay, heap, what it contains? In by using the heap, we are going to allocate the memory dynamically. So there is a difference between the allocation of the memory dynamically and statically. When you declare the inti in the program, so that means we are going to allocate the memory statically, because we are going to tell the compiler which kind of a memory allocate to the I at the compile time. But in the runtime, what is going to be happens when the program is going to be in a run situation, at that time we are going to allocate the memory. So there are some advantages to allocate the memory at the runtime. So these are the multiple parts of the processes, and these are the things are contained into that parts. So this is about this slide. We have seen the definition of the process, then different parts of the process, and when we are going to consider the batch system, we know about the different operating systems evolution. At the batch system, it is considered as a job, and in the time sharing system nowadays, all the time sharing systems we are going to use it, so it is considered as a program. Then we will move to the next slide. So there is a, we always talk about this one, that is there is a difference between the program and the process. So program is the passive entity stored on the disk, or it is a executable file, but it is a passive entity and stored on the disk. whereas process is an active entity. What is meant by the process? The process is an active entity that we have loaded into the memory for the execution purpose, and it is going to be executed now. So that is nothing but the process. So there is a always difference between the program and process. Just like that one, we can say program is a passive entity, whereas the process is an active entity. So about the next point, program becomes a process when executable file loaded into the memory. Okay, when program becomes a process, when it is going to be loaded into the memory and the execution is going to be started, then your program becomes a process. Then the next point, execution of the program started via the GUI mouse click command line entry of its name. Okay, how we are going to run the program? Just like any exe file that you have downloaded from the internet. Okay, and suppose I want to run it, so simply you can double click on that and you are going to run your program. Or by using the command prompt, you can give the any command like ls-l. You can simply enter, then your program is going to be run. Means your program is now converted to the process and it is going to be run by the operating system. One program can be several processes. So one program have the many processes. Consider the multiple users executing the same program. Okay, when there are the number of users are there, multiple users are there, the same program can be executable by the executed by the many of the users. So one program can have the several processes just like this one, because we are in the today's operating system, we have the multiple users and multiple users can act at the same time. So it can going to be access that program and it can run the program. So one program have the several processes. We'll move to the next slide. Okay, here they have drawn the one diagram related to the process in a memory. This is about the text, where these are the different parts about the your memory. The first one consists the text, then next one consists the data, then next one heap, and another one as a stack. Okay, so simply these are the different parts. The first one is the text. What it contains? The text contains the compile code. What the data contains? Data contains the static and global variables in the program. What the use of the heap? Use of the heap is about the allocation of the memory at the runtime. Then what is the use of the stack? To store the temporary variable addresses and return variables. Okay, and what it means, this 0 and max contains, this is the memory allocated to the process. Okay, 0 to max. Okay, it depends on the memory. You can ask me the question, what is the max? The max is nothing but the maximum memory size allocated to that process. And how is going to be decided? The depend on that process, which kind of a process that one. Okay, this is about the max. Okay, this is the diagram. You need to remember it for the different parts of the memory. When there is a question in your question paper is about the uh, uh, parts of the processes, then you need to draw this diagram and you have to explain these all the parts of the processes. Okay, I hope these all the concepts are cleared related to the process basics, definition of the process and the parts of the process. Then we will go to the next important point as a process state. So we have the 5 process states. When we are thinking about the creation of the process, then how it is going to be actually go into different steps when it is about to be created and it is about to be terminated. When we are thinking about the executing the command ls-l, then that ls-l, it is to be created, it is in a running condition. If it requires some kind of a input output, then it is going to into wait condition. Again, all the resources are ready with it, but it is waiting for the execution, then that is the ready step, and then at the last step it is a terminated. So these are the process states related with the any kind of a process. So this I will show you the diagram related with the process step. So you need to remember the 5 state with the processes. The when creation of the process up to the termination process, which are the different state are process having it. So there are the 5 states, which is the new, running, waiting, ready, and terminated. So you have to remember it. Where there are the different 5 states are with the your process, and how you are going to do it. So in this diagram you can see this one. When I will uh, new process comes, it is in the new state. Okay, simply we can say it is the admitted new process. Okay, when the new process admitted, we are going to assign the all resources to that one. If all resources are with the that process, then it is in a ready state. Okay, now the scheduler decide that I want to execute that process, then that process is going to be go into the running state now. Okay, and after the running state all the execution is completed, then it is into the exit mode, it is going to be terminated. Okay, if okay, now we seen the new, ready, running, and terminated. What about these two states? Okay, now you can suppose that the ready state, the your process is going to be into running state, but it wants some kind of a input output, but it your input output busy at some state, then it is going to be in a waiting state. Okay, after input output is going to be available, then again it going to be in a ready state, and again scheduler dispatch the process and it goes into run, and then going to the terminated. Okay, this is about the waiting state here. Then again, what is about the interrupt? If the process 1 is here, and just in time the process 2 is going to be came, and the process 2 has the more priority than the process 1, then your process 1 is going to be stop here, and process 2 is going to be run. So what thing happen with the process 1? Process 1 is going to be terminated and again go into the ready state. After completion of the process 2, then again the process is going to be run, and again it is going to be terminated. So this is about the process state, how the process is going to be executed in your operating system environment. So this is nothing about the this is nothing but the process state. These are the different process states related with the your operating system environment. Then about the process control block. So every process is having the process control block. How parameters related with the process is going to be stored into the operating system. So how it is going to be stored with using the process control block. So this is the another important point from your process management, that is the PCB. Generally it is called as a PCB, or sometimes it is also called as a task control block, that is nothing but the TCB. Okay, mainly it is referred as the process control block, that is nothing but the PCB. Okay, then what the PCB contains? The PCB contains the process state. Okay, which are the different process state? Swapnali, can you give the answer? Which are the different process state?
न्यू स्टेट नाही न्यू रनिंग वेटिंग रेडी आणि टर्मिनेटेड.
Okay, good. Which are the different state? Okay, the current state of the process is stored into the process state. Okay, then what is the program counter? Okay, means location of the instruction next to execute, that is nothing but the program counter, that is also contained here. Then about the CPU register. Okay, then what is the use of the CPU register and which different kind of a CPU registers are included in the PCB? So just like accumulators, index registers, your stack pointers, general purpose registers, then condition code information registers. So these are the different kinds of the registers are included in your simply we can say it is on the motherboard or the simply on a your operating your system. So we have the different use of these registers in the process evaluation or the process completion. These registers are going to be used, and the related with that process, all the registers are stored into the PCB. So every process has its own PCB. Means when the process is going to be created, then that PCB is going to be allocated to that process, and that PCB is responsible for storing the all information or the all the data related with that process. So this is nothing but the PCB, process control block. Then the CPU scheduling information means priorities for that process, which priorities are having with that process. Then scheduling queue pointers. Okay, we have the different scheduling queues. Okay, we'll see it into the some of the next slides. Okay, we'll see about the queues. But now you just remember that the CPU scheduling information is also stored it into the PCB. Okay, in the diagram all the things are not listed here, but we have to remember this all the one. The next one as the memory management information. The memory management information, how the memory is allocated to the process and how many address locations are given to that one. So this information also stored it here. Memory limits, then accounting information, just like cp used by that process, then clock time elapsed since start, when it is going to be started, then up to which time we are going to execute it, time limits. These all accounting information is stored into the PCB. Then IO status information, input output devices allocated to processes, and list of the open files. Means that everything is related with that process is going to be stored into the PCB, process control block. I think now you have understood what is the use of the PCB. Okay, when we are going to allocate, when the process is going to be generated, then that process is allocated the PCB to it, and that PCB is responsible to store all the information related to the PCB. So which kind of information? The information can be a process state. Okay, just now we have seen the process state, the process number associated with that process, program counter, register, memory limit, then list of the open files, and all other parameters like a memory management, CPU scheduling information, and all the things related with that process is going to be stored into the process control block. Okay, so this is about the PCB. This is the thing you have to remember it. This is the very much important in the operating system, that is nothing but the PCB. Many of the question can be asked on the PCB. Okay, so we know about the CPU can switch the from process to process. When the process P0, okay, in the diagram, when we see the diagram, it is going to be some quite complicated. We can determine that, but this is the very easy diagram. Okay, I will show you how it is going to be very easy. Okay, now your operating system having the two process 0, process 1. Okay, in the today's state, then the process P0 is going to be in a executing state. Okay, but some kind of a interrupt or the system call is going to be generated. Okay, then what things are going to be happen? Then first of all we need to save the state into the PCB0. Why we are going to save this all the state into the PCB0? Because we need to execute it after the some time. So when the process 1 is going 0 is going to be stopped and process 1 is going to be run. So first of all, what the thing we have to do, we have to do the save state into the PCB 0. Okay, then at this time your process 1 is idle. What is mean by the idle? It is going to be sit idly. Nothing is going to be happen for the process 1. Okay, now reload state from the PCB1. Okay, we know that every process is having its own PCB. So at this time the process 1 PCB is going to be loaded into the memory and it is going to be in a executing step here. Okay, then process 1 is going to be executed. Then we know that the again any kind of an interrupt, or suppose we can uh, see that we can say that the process 1 is going to be stop or it is going to be completed. Then again save the this PCB, all the state of that process into the PCB 1. Okay, then we need to execute the process 0. So reload the state PCB of the PCB 0 here, and again the your P0 process is going to be executed mode. Okay, so hopefully this diagram is going to be understood by the everyone. So it is a very easy diagram. The process 1 first of all in the executing step, but some kind of a interrupt comes. So save the PCB 0. I want to execute the process 1, so load that PCB of 1, execute it. If any kind of interrupt or the system call comes, then again save that PCB 1, and at that time you have to load again PCB 0 and again start the PCB 1. So this is nothing but the CPU switch from process to process. When one process runs, then again another process come. Okay, that time that CPU want to execute it, then how it is going to be switching comes between the process to process. So this diagram, what it defines, this diagram defines the process switching, or how CPU is going to be switched from process to process. Then next point about the threads. Okay, in the Java programming you have the concept like a multi-threading. Okay, what is mean by the multi-threading? So we can understood that one, that is the process has the single thread of execution. Okay, then consider having the multiple counters per process. The multiple location can execute at the once multiple threads of the control, that is nothing but the threads. Okay, when we have the one program but having the multiple program counters per process, having the multiple program counter per process, we have the one process only, but in that one process we are having the multiple program counters, so we can execute that simultaneously. So that is nothing but called as a threads. It is just like a concept in your Java program. It is a multi-threading. So when we are going to simultaneously execute these all the threads, so each thread having its separate PCB. Okay, that is mentioned here. Each thread having the separate PCB, having own static thread details, multiple program counters in a PCB. Okay, so this is about the threads. In one program you can have the multiple threads. Okay, then how the process is going to be represented in the Linux platform? Okay, how we are going to represent it? Okay, by using the simple structure we are going to represent it. Okay, how we can simply define the structure task underscore struct. We have the PID as a process ID. Then this contains the long state, means this is the information related to the state. Then unsigned int time underscore slide, this is about the scheduling information, up to how many time we are going to execute it. Then this is the pointer to the your parent process. Then this is the pointer again to the child process. Okay, if in future it is going to be uh, there is a need of creating the any kind of a process by the same one by using the fork system call from the Linux operating system. So that again pointing to the children. Then list of file opens, this is the pointer to the required files to that process, and this is the memory address space to the this process. This is the again this is the different structure type, whereas it locate to the memory structure. So how we are going to locate it in the Linux operating system? How, suppose I have told you write the program for the define one process, and which are the different parameters. We can simply write the one of the structure in your C program, and which contains the PID, then state, then time slide, then the pointers to the parent process, child process, files required, and the memory. So this type this type we can define your process in a Linux platform. This is the just idea how so we can think about how we are going to declare the your process structure in the Linux operating system. So this is about the today's lecture. We have completed the many of the things, like a process concept, again definition of process, then parts of the process, then um, this is the diagram related with the parts of the process, then the process state. We have the 5 process state, how your process is going to be moved from one state to another one, we have discussed that one. Then every process is having its own PCB related with that one, and which use of these all the blocks we have discussed. Suppose your CPU switch from process to process, then how that process is going to be done, what is the sequence of the switching from the process to process for that CPU we have discussed. Then about the what is meant by threads, and suppose I want to represent it into the Linux platform or the in a simple C language, then which are the parameters are included into your structure that we have discussed. So we'll stop it here, and suppose you have any kind of a doubt, you can ask it.